What's the value of a stock that has a dividend that grows at a constant rate? And specifically, suppose we have our next dividend in one period, and then after that, all dividends grow at a constant rate of G. Well, the price is reflected by this horrible expression, which, you got the dividend in 1 year plus the expected dividend in 2 years, which is the dividend 1 times 1 plus G, discounted back 2 periods, plus the D3 all the way out. What's nice is that really, really cumbersome expression simplifies to something quite nice. That if we have a case where we have D1 and then after that all dividends grow at a constant rate, the price of that stock today is equal to D1, the expected dividend in 1 period, divided by R minus G. And through algebra, this expression simplifies to these three expressions so that if you're trying to find the expected return with a stock that has a dividend that grows at a constant rate, if you want to know what the next dividend is for a stock that has a dividend that's expected to grow at a constant rate, or if you just want to know what that growth rate is. And again, we're dealing with a situation where you've got the next dividend and then constant growth after that. You have expressions for that. More generally, go to any point in time, call it time t. These dividends don't matter because they got paid in the morning. You jump out of the time machine in the afternoon and you want to say, hey, how much is my dividend worth? Well, look, in 1 period, I have this expected dividend. And then after that, all dividends are expected to increase by constant growth rate G. So what is the price of the stock at time t? Well, the expected price at time t is simply equal to the dividend 1 period later, which is the dividend at time t plus 1, all over R minus G. And then you've got expressions there for each of the components, which is just an algebraic manipulation of this expression. So again, what we're really doing is, you can, let's say you want to know what the expected price is in time 5. If in time 6 you expect a dividend, and then after that all the dividends are expected to grow. I'm sorry. Here's time 5. You have the dividend at time 6, and after that they all grow at a constant rate. You can simply get into your time machine, call this time 0, this time 1, this time 2, this time 3, and you can see what's the expected price the day you jump out. You get a dividend 1 period later, and after that constant growth, this is the appropriate expression, the appropriate model. So one of the assumptions we're going to make, and this is a common assumption that you need to make in order to use this model, is that the growth rate is less than the discount rate. If it wasn't the case, then basically the dividends would be growing so fast that their present values would be increasing over time, and so the value of our stock would be infinite, and you wouldn't have anything to work with. If you have a case where growth is less, the assumption we're making, even though the dividends are getting bigger and bigger and bigger, their present values are getting smaller and smaller, and so there's actually a finite value to an infinite stream of those dividends. And again, we've talked about this. The growth rate at G, it tells us what the dividends are expected to be at different points in time. We expect this company to write checks every period forever and ever and ever. If we know what the next dividend is, the D1, and we know what the growth rate is, we can figure out what the dividend is expected to be at any point in time. Or if we know the dividend at any 2 points in time, we can back out G, and if we know the dividend at any 1 point in time and we know the growth rate, we can figure out what the dividend is going to be at any other point in time. It tells us about what those checks are supposed to be. R, it's the relevant discount rate, the expected return for a period, whether it's a quarter or a year, and it tells us how much a particular dividend or how much a particular cash flow is worth at a point in time. What's its present value? So again, it's an understanding that the difference between G and R. So Aspen Corp, this is a stock that has an annual expected return of 20%. In 1 year, it pays a dividend of $2, and after that, dividends are expected to grow by 5% a year forever. So they grow from 2 to 210 to 220.05 to, if you do it out, 231.5, forever and ever and ever. Well, this is a case where we can use our constant growth, because if we were here, we'd say, hey, look, $2, After that, it grows by 5%. So I can apply my model. $2 divided by 20% minus 5% is equal to 1333. So again, you have a nice equation, but what's important is recognize why you can use it, because if you're in at time zero when we're trying to find the price as of one period later, constant growth, that's what gives it to you. So we want to know what the value of a stock that's expected to pay quarterly dividends. So expected return is 8% per year. So what do we know about that? We know that that is 2% per quarter. And we know that the next dividend is expected in 3 months, and that's going to be $1. And after that, all subsequent dividends are expected to grow by 0.5%. So we expect it to go from $1 to $1.50. So a little bit more than $1.01 forever and ever and ever. What's the value of this stock? Well, we can apply our model because here we are, $1 in one period, after that growth by 0.5%. As noted, it's 8% per year, so you need 2% for each quarter. What's the value of the stock? $66.67. $1 divided by R minus G. R 8% per year, 2% per quarter, G 0.5%, 66.67. What if we have a stock that's also expected to pay $1 in 3 months, also has an expected return of 8% per year, so it's 2% per quarter, but now dividends are expected to grow by 1% per quarter? Well, then dividends $1, $1, a little over $2, a little over $3, $4, it's going to increase by 1% forever. So compared to the other stock, this has the same discount rate, the same cash flow in one period, but after that, all cash flows are expected to be higher with this stock than the one we just looked at. We'd expect it to have a higher value, and in fact it does. This stock is worth $100 because we've got the higher growth rate. So all else equal, so if we have the next expected dividend constant, the expected payment schedule constant, so we have two stocks that are paid at the same time periods, and expected return is the same, then as the dividend growth rate increases, value increases as well. And again, that should make sense. That what is dividend growth? It just means that future expected dividends are expected to be higher. Higher dividends, more value, all else equal. So now here's the stock, $1.25, that's going to grow by 0.5%, but now the expected return is only 4% per year, which is 1% per quarter. So relative to the first stock we looked at, it has the exact same expected cash flows, $1 and then grow by 0.5%, but this one's less risky. It has an expected return only of 4% per year, which is 1% per quarter. So if we're discounting the same cash flows by less, we would expect to have a higher value, and in fact we do, $200. So again, 1% per quarter, $1 over R minus G. And what we're really saying is that $1 divided by 1.01 plus $1.50 divided by 1.01 squared plus $1.01 and a little bit more divided by 1.01 to the third forever and ever and ever is equal to $200. And so again, all else equal, that if the next expected dividend is the same, the expected payment and the expected dividend growth rate are the same, meaning that the expected cash flows are the same, as the expected return goes down, value goes up. And again, that makes intuitive sense that if you're, have two situations that have the exact same cash flows, the ones with the lower expected return has a lower discount rate, so it's the cash flows are discounted. The value of the cash flows is discounted by less, and so it retains more value, and stock value is higher. So now we want to know what's the value of a stock expected to be in 5 years. Stock pays annual dividends forever, starting in a year, 8% per year. Everything looks like years so far. The dividend in 5 years is expected to be $4, and all subsequent dividends are expected to grow by 3% per year. So this is a problem where you really need to be careful because it's so tempted. You see a dividend of $4, all subsequent dividends grow by 3. You have return of 8% per year. And so it would be so tempting to say $4, that's my dividend, over R minus G. Here's the issue. Here's your timeline. We're trying to find P5. Therefore, we have $4 and then a constant growth rate, but we're trying to find P5, and so we need the next dividend. We need P5 equal to D6 over R minus G. So we get out of our time machine here. Remember, we get out in the afternoon, the $4 already been paid, but we look, the next dividend's $4.12, and then after that, they all grow at a constant rate of 3%. You know, this 424 is actually 412 times 1.03. The next one will be 4.2436 times 1.03, and they'll continue forever. So look, here we are at time 5. We get the next dividend. They all grow at a constant rate. This expression's appropriate. But we're not given D6. We're given D5, but we're also given a growth rate. So what's D6? D6 is $4.12. $4 grow by 3% gets you to 412. We know R is 8% and G is 3%. And therefore the expected price in 5 years is 82.40. So you want to be real careful not to simply say 4 divided by R minus G, because the $4 is the dividend in 5 years and you need the dividend in 6 years. So you want to set your plan, identify what you have, and then go about incorporating what you know. You got R and G. You don't have D6, but you have D5 and G, and that's how you can go ahead and approach a problem like this. And again, notice P4 is equal to D5 over R minus G. So if you just stuck that in and come up with $80, you wouldn't be getting the expected price in 5 years. You'd actually be getting the expected price in 4 years. And what we see is that if the dividend is expected to grow at a constant rate, the price of the stock also grows forever at that same constant rate. So we want to know what the dividend is expected to be in 3 months, so in 1 quarter. Stock pays every dividend a quarter forever, 10% per year, which is equivalent to 2.5% per quarter. That's the rate we're going to need because we're in a quarterly world. Next dividend is expected in 3 months, so in 3 months we're expecting a dividend. And all subsequent dividends grow by 1% per quarter, and the stock's priced at 40. So we know that 40 is equal to D1 over 1.025 plus D2 over 1.025 squared, but D2 is equal to D1 times 1.01. And you can get a really complicated expression, but we can say, aha, look, P0, which is equal to 40, is equal to D1 over R minus G, because you get D1, and then after that the growth rate's 1%. Do a little bit of algebra, and we have an expression for D1. It's the current price, which is 40, times R minus G, which is 1% per quarter and 2.5% per quarter. So therefore, 40 times R minus G is equal to $40 times 15 cents. The dividend that's expected in 1 period is 60 cents. What is the expected annual return? We have a stock, it pays a dividend every quarter. So again, we're in a quarter world, but we want the expected annual return. So you don't want to forget that. Next dividend is expected to be $2. All subsequent dividends are expected to grow by 1%. So we got 2, then 202, then a little over 204, then we're going to have a little over 206, and they're going to continue growing by 1%. And the stock is priced at $44. So again, here we are. We know the price of the stock is equal to 2, which is the next dividend, over R minus G, because after the 2, all the stocks grow at a constant rate. Do a little bit of algebra, and you get an expression that R is equal to the next dividend over the current price, plus the growth rate. Well, D1 is given as $2. The price is given as $44. The growth rate is given as 1%. So the R, the discount rate, is 5.545%. However, this is the rate for a quarter, so you need to multiply it by 4 times to annualize it. And so the expected annual return is 22.18%. Finally, what is the expected quarterly growth rate for a stock's dividend? The stock pays a dividend every quarter forever. In 3 months, we expect it to be $2. All subsequent dividends are going to grow at the same rate. So again, you got 2 times 1 plus g, 2 times 1 plus g squared, all the way out forever and ever. The stock is priced at $74, and the expected quarterly return is 3.5%. So everything that we're given is in terms of quarters. So again, we can say, aha, the price today, that 74, is equal to 2 over r minus g, because we're told that it grows at a constant rate. We just want to know what is that rate so that the present value of this infinite stream of dividends discounted by 3.5% per quarter is equal to 74. Well, if you do some algebra, g, the growth rate, is equal to r, which we're given as 3%, minus d1, which is $2 over p0, which is $74. And we see that the growth rate is just under 0.8%.